Okay, there you go. Is everybody able to see the screen? Let me know if you can't see. Is that all right? Okay, yes, I think the screen is clear. Okay, great. All right, so here we go. All right, the lesson objectives today, all right, it's mentioned will be on area of triangles, identifying the base and height, and of course, finding the area of triangle using the area of triangle formula. Okay. So just a quick show of hands to see how many of you have already completed this topic, or have you not seen this topic yet? In school, I mean. Anyone is brand new or encountering this topic for the very, very first time? Anybody? Gordon, okay, I see Gordon's hand. What about the rest? Have you seen this topic before? Have you gone through the concepts in this topic already? Dan, how about you? Done? Not yet? Yes? Okay. All right. Let's just get a rough idea to see how much do you already know about this topic. Okay, I know some of you already tried the questions. You get an idea of how this works. Okay, for those who look at it for the first time, don't worry because we'll be covering from the basics from the beginning anyway. Okay, so let's see what we have. Oops. Okay, so in this first part here, we are going to identify the height given the base AD. Okay. All right. Yeah, some of you, I know you are halfway through this topic. Some of you have already completed, but let's see. Okay, yeah, thanks, Liana. As always, very fast with your answer. Thank you. So what do we mean by the base and height? Okay, so just for the first few questions, maybe I'll just go a little bit slower just to ensure that those who have not covered this topic yet, or maybe you're just halfway in, you will at least have a better idea how this works. So there are two things as always for this concept on area of triangles. We need to know the height and the base. All right. Yes, thank you, Tanishka, you're right. So we're asked to identify the height, but we are given the base, isn't it? Okay, so they mentioned that the base is AD. So where is AD? Let's see. AD is here. Okay, so that's the base AD. So how do we know where the height is? The height, okay, the first rule is that it must always be perpendicular, all right, perpendicular to the base. The base and height must be perpendicular, that means. Okay. All right. Yeah, those who have typed in the chat box, all of you are correct so far. Very good. Okay. So the first rule is that, sorry, yeah, type here. The first important rule is that the base and height must be perpendicular. Base and height. It's perpendicular. Okay, perpendicular means, say, they are 90 degrees to each other. Okay. Oops, sorry. It's a bit slow to write. Okay, must be perpendicular to each other. So that's the first important rule. Now, since I say it's the first important rule, is there a second rule that we can use to talk about this? What is the second rule? Or does anybody have a second rule? Yeah, the answer is CU for sure. No doubt about it. Base perpendicular, the height perpendicular 90 degrees. Yes, what is another thing that we can observe? Of course, this is the most important rule already, because if this fails, that means completely cannot be a pair of base and height. Okay. Let's see. Okay, there you go, the perpendicular. So I came out with a second rule to address some issues, because sometimes, even though you have identified the perpendicular base and height, it may not necessarily be the correct base and height. Okay, I see Liana saying something. It must reach the highest point of the triangle. Yes, in a way, it's the highest point of the triangle, depending on where the base and height, where the base is relative to the height. Yes. Okay, so I came out with this second rule. You see whether you all can understand. Let me write it out as well. Okay, so a second rule is the heights, okay, which is the height that you identify must be correct. The height must be able to pass through the opposite point to the base. Okay, I say must be able to, all right, because sometimes when we identify the height, we need not, all right, draw a line that must go through that, as long as it can, all right, that's what I'm saying. Must be able to pass through. Okay, like what Liana mentioned, all right, in the chat. Okay, she mentioned something like the highest point of the triangle. Okay, also can. Okay, for me, I like to say it must be able to pass through the opposite. Okay, so let me type that out first. Apologies if I'm a bit slow in typing out because I'm using the this program. Okay, opposite. Oh no, sorry, spelling. Opposite to pass through the opposite to the base. At the tip of the triangle. Okay, so later when you see more examples, you'll see how this rule actually can apply. So for the very basic triangles, okay, it doesn't really matter because as you can see, the base height, okay, this is a height, as the opposite tip as I was referring to, okay, opposite to the base, because a triangle only has three tips, isn't it? In this case, it'll be A, D, and U. So if AD is the base, the opposite tip that I'm referring to obviously has to be U. There's no other point already, as you can see. So it forms a perpendicular, the first important rule, and it can pass through the point U, which is the opposite tip. Okay. So sometimes in some questions, they will give another point, okay? And then as you can see, as long as it's able to reflect the same height, it is the correct height that you're using. Okay, so if let's say I draw another line here, okay, it is also 90 degrees. So why can't I say that this line is a height? Simply because it doesn't pass through the opposite point. It cannot pass through the opposite point because it's too little. Okay. So let me just throw out those important points to identify the subsequent base and heights. Okay, yeah, and those answers that y'all gave me in the chat box are perfectly correct. Very good. Okay, so that's the first example. And is there any questions before we look at the next one? Oh, hi, hello. I saw, I think, is it Kiara? Sorry, let me know how to pronounce your name if I say it wrongly. All right.
Kiara.
Kiara. Okay, sure. Kiara, right? Okay. All right. Welcome. Welcome. Okay. All right. Let's look at the next one. Yeah, that's right. Vishal, you're correct. Okay. Okay, so some of y'all mentioned CU, some of y'all mentioned UC. It doesn't matter. Both are correct. Okay. Let's try another slightly different triangle. All right, let's see whether we can apply the same rules that I was saying in the previous, in the example there. Okay. Okay, so I see Liana and Tanishka's answer already. Okay, let's find out what is this all about. The figure is not drawn to scale. PQ is the base. All right, so you can identify PQ first. So specifically, they want us to use PQ as the base, right? Base of the triangle PQD. Now take note, the dotted lines are not part of the triangle. Okay, meaning to say the main triangle that we're dealing with is PQD. Only these three main vertices. Okay, the vertex. Huh? So for point F and point R, all right, they are just reference points for us to use. Okay. Okay, yeah, so those who just came in, welcome, welcome. Okay, we're at the second question. Okay. Now, so question is, what is the height of triangle PQD? All right, height of triangle PQD.
Sorry, I'm late.
Yeah, no worries. So as mentioned, we have already identified the base, right? In this case, it is given to us. PQ is a base. So what is the condition again to establish the height? Remember in the previous example, what did I say? The two rules. The first rule, the most important, is that it must be perpendicular, right? So what is the perpendicular that we're using? Can we just say that, hey, this is the height, isn't it? QF. Can we say that QF is a height? Can or cannot? I know those who gave me the answer obviously will tell me cannot, right? So yes, why is the reason why we cannot use QF? Well, it's perpendicular, isn't it? So why isn't it not the correct height to use? We said that the height must be perpendicular to the base, right? And the base is PQ. So QF is perpendicular. So why can't we use that as the height then? Let me erase this one first. Okay. Yeah, so let's see what did some of you say. It did not reach the tip. Thank you, Liana. All right. Yeah, so Liana also gave us another way of presenting it. All right, she mentioned that you must be able to, all right, touch the opposite tip, must go through the opposite tip. And remember, I was saying as well, there are only 3 points on the triangle, P, Q, and D. So if PQ is the base, it is very clear that the opposite tip must be the point D. All right. So if the height doesn't pass through D, or it cannot pass through D, in this case QF, then QF cannot qualify as the height. All right, even though it's perpendicular. So having just one satisfied the perpendicular condition is not good enough. Okay, so what is the height then? Answer DQ. Okay, yes, no, not DQ. DQ is not perpendicular. All right. Now, so that's another common issue we need to look out for. Firstly, we need to make sure that we check for perpendicular. Okay, so perpendicular can be QF, but we said QF is not the answer because it failed the second test, which is perpendicular. Which is to be able to pass through the opposite tip, which I circled there. Okay, so therefore, the perpendicular, you have to draw the extra lines which is outside the triangle. That's why I was saying just now, it is not part of the triangle, but not an issue. The perpendicular height must be able to pass through the tip, which is point D. Therefore, the height is dr. Okay? Yeah, dr or rd is fine. Okay, because we don't distinguish between which point comes first. It doesn't matter. Okay. Yeah, so I just also make use of what Liana mentioned as well, because I think that's also another very good way of saying the height must be able to pass through the opposite to the base, to the base of at the tip of the triangle. Okay, I think that's quite similar to what I said as well. Okay, so QF, conclusion, QF cannot be the height. Okay, because QF, although it is perpendicular, it doesn't pass through D. All right, you can see the difference, right? QF is much shorter than DR. Therefore, if you had used QF as the height, that means you will not be finding the full complete area of triangle PQD. Okay, you are only finding the area of triangle PQF, but that will be wrong, isn't it? So in order to find the area of triangle PQD, your height need to extend a little bit more. So that's why we have to use dr as the correct height. So even though r is not inside the triangle, it's okay. is okay. The base must be in the triangle, but the height, all right, doesn't necessarily